This is a review of vectors, component form, and magnitude. Let's start with our first sample problem. Draw and label a vector, A, with these components. So remember that this is a special way of writing an ordered pair. That means a change in X and a change in Y. So anywhere on the grid, we'll just start at 0, 0. If it's on the problem online, it'll tell you where to start from. But for this one, you can start anywhere. So I started this one at 0, 0, and I go 5 negative, or in the negative direction at X, and 2 positive for Y. And then I draw my vector going from the origin to that point. And I didn't do a great job, but there it is. Okay, now let's go with the second problem. Second problem is the vector B has an initial point of 14 and negative 23 and a terminal point of negative 8 and negative 15. You may recall that we had set it up so that we take the terminal point and we subtract the initial to get the resultant component form. So, or not it was the resultant vector, right? We write it in component form like this. Same kind of thing, but I think that's more clear. Okay, so we'll go ahead and start. We start with negative 8 and negative 15 minus 14 minus 23. Okay, so if we go negative 8 and subtract 14, we will get negative 22. And we take negative 15 and we minus a minus 23. Remember that kind of makes it into a plus here, right? So that's like negative 15 plus 23. That gives us 8. So the component form of the new vector, or of this vector, is negative 22, 8. Sample problem 3, we want to find the exact and approximate magnitudes of the following vectors. This will be the same for the next 3 problems. Round where needed to the nearest hundredth. So for this one, remember we want to start at the initial value and work our way in the X direction or Y direction. We'll go Y direction this time. Looks like we're going 5 units. I'm not worried right now about direction, so I'm not going to write the negative. That'll help me out when I start doing the calculations. Let's see, and we're going to go in the, how long is this side? 1, 2, 3, 4, 5, 6, 7, 8. So this is 8. Now to find the length of the vector, which is the magnitude, we're going to use the missing side, the hypotenuse of a triangle, which is the a squared plus b squared. So we will do the square root 5 squared plus 8 squared equals the square root of 89. That goes here in the first part. And then we punch that into the calculator and we get 9,4,339. It goes on. So this would be, if we're going to the nearest hundredth, we'll look at this digit here, 43. Okay, that was number 3. For number 4, find the exact and approximate magnitudes of the following vectors. Okay, so this time we have vector D, and it's given to us in component form. So the nice thing about that is we could plot it out on a grid like this and start at 0 and go right 8 and up 14 like this. But this is already set up. We know the lengths of the change in x is 8. And we know the change of y is 14, so we can just plug it in. 8 squared plus 14 squared gives us square root of 260, and that is approximately 16.124. So we put these down in here with the square root of 260 and 16.12. Okay, for problem number 5, very similar to the paper problems here. We want to find the exact and approximate magnitude of this vector. Well, we're going to have to find out what the vector is first to get it in component form. So we'll go ahead and set it up. We've got the terminal point. We've already got it here, so I'm just going to rewrite the initial point underneath. Set it up like a subtraction problem. Now if I do 20 minus a minus 12, of course that's 32, and 9 minus 5 is 4. So that if I punch this into the calculator, I get the square root of 1040, and I get the approximate of 32.25. Then my last one of this example is write the components for a different vector f that has the exact same magnitude as vector g. And what we're to recognize on this one, some of us made this really hard on the homework earlier on, but we just need to recognize that if I have a vector that goes 7 and 16, it's going to be about like this, where this is 7, I know it's not quite to scale, and this is 16. If I were to go exactly opposite, coming down this way, then this would be -7, -16. And so I know I have one vector here that I just change everybody's sign. And we actually find out that there's several different possible combinations where we just write it out. So that's the simplest way. It's just anything that has a 7 and 16 in it with different signs. So this could be one possible combination. We'll also have the same magnitude. Or for those that aren't of the faint of heart, you could actually calculate the magnitude, and I'm just going to say magnitude here. And then this number could be a vector that goes the value of that magnitude and 0. You can try that out with some simpler ones if you'd like. But that makes it harder. You're certainly welcome to do that if you want. There we go. That's number 6. So we're asking you to do these problems and get them turned in as quickly as you can. There's both paper and online version. Good luck to you, and well, it'll be nice when this is done, isn't it? Okay, we'll see you. Bye.